Right now, beneath the bustling streets of a major European city, the ground is slowly acting like a giant loaf of bread rising in an oven. Millions of people walk over a sleeping monster every single day without realizing that the stone beneath their feet is actively stretching, cracking, and pushing upward. This is not a slow geological change that takes millions of years. It is happening right this second while you are listening. Every tremor and every shifted brick tells a story of immense underground pressure building toward a breaking point that scientists are racing to understand. If you love uncovering the real science behind our planet without any exaggeration, make sure to hit subscribe and join our growing community of curious minds. Deep beneath the sunny coastline of southern Italy lies a massive volcanic system known as Campi Flegrei, which translates directly from ancient words to mean the burning fields. Unlike a typical tall mountain volcano shaped like a cone, this system is a giant sunken bowl called a caldera, measuring about 12 kilometers or 7.5 miles wide. Most of this volatile zone sits quietly right next to the historic city of Naples and stretches out under the blue waters of the Gulf of Pozzuoli. Over 500,000 people currently live directly inside this danger zone, making it one of the most heavily populated volcanic hotspots found anywhere on Earth. To truly understand what makes Campi Flegrei so unique and dangerous, we have to look closely at how a caldera forms compared to a traditional volcano. When most people think of a volcano, they picture a mountain like Mount Vesuvius or Mount Fuji, with a crater at the very top. These tall mountains build up over thousands of years as lava flows out, cools down, and stacks layer upon layer of hard rock. Calderas, on the other hand, are created by eruptions so huge and sudden that the ground collapses inward on itself. When a massive underground magma chamber empties out during a super eruption, the rock ceiling above it loses its support and drops down into the empty space. This creates a vast depression in the earth, shaped almost like a huge dinner plate or a shallow bowl. Over centuries, wind, rain, and ocean water fill in the depression, hiding the true nature of the giant volcano beneath fields, forests, cities, and shallow coastal bays. People can walk across a caldera for miles without ever realizing they are standing right inside the mouth of a giant subterranean volcano. The history of Campi Flegrei goes back tens of thousands of years, long before modern human cities existed in Europe. Geologists studying ancient rock layers have discovered that this region experienced two enormous eruptions in its prehistoric past. The first major event, known as the Campanian Ignimbrite eruption, occurred roughly 39,000 years ago. It was one of the largest volcanic explosions in Europe over the last 200,000 years, throwing hundreds of cubic kilometers of ash, gas, and molten rock into the atmosphere. That ancient prehistoric blast sent dark clouds of ash sailing across the continent, blocking out sunlight and lowering temperatures across Europe for several years. The heavy layer of volcanic ash covered thousands of square miles, wiping out local plants and forcing early humans and animals to migrate or perish. Scientists believe that this huge climatic disruption may have played a major role in the downfall of the Neanderthals, who were already struggling to survive in a changing climate. The sheer scale of that single explosion redefined the landscape of southern Italy and carved out the original outline of the giant caldera we see today. Thousands of years later, approximately 15,000 years ago, the volcano erupted again in another massive event known as the Neapolitan yellow tuff eruption. While not quite as large as the first blast, it still threw huge amounts of hot ash and fragmented rock into the sky. When this material rained back down onto the land, it compressed and hardened into a yellowish stone called tuff. Ancient people later used this soft yellow stone to build roads, bridges, and homes throughout the region, literally building human civilization out of the ash of past volcanic catastrophes. For thousands of years after those ancient events, the sunken bowl of Campi Flegrei seemed to settle into a peaceful state. The fertile soil created by old volcanic ash made the area perfect for farming, and the coastline offered natural harbors for fishing and trade. The ancient Greeks and Romans fell in love with the mild climate, picturesque ocean views, and warm thermal springs that popped up all over the landscape. Emperors, generals, and wealthy citizens built luxurious vacation villas along the shores of Pozzuoli and Baiae, soaking in hot pools fed by geothermal heat from deep below. The Romans knew that hot springs and bubbling steam vents meant heat existed underground, but they did not realize they were sitting on top of an active caldera. They attributed the warm waters and sulfur gas to underground rivers heated by mythological forces or deep earth spirits. For many centuries, the region remained quiet, and generations of families lived their entire lives without experiencing anything more dramatic than occasional sulfur smells or mild earth shakes. The land was so pleasant and productive that nobody had any reason to suspect that a sleeping giant was quietly stirring underneath their feet. Did you know that ancient Roman ruins submerged underwater near Naples are actually proof that the ground has been rising and falling for thousands of years? Drop a comment below if you find it amazing how archaeology and geology connect, and be sure to hit that like button to help more people discover this incredible real-world science. That long era of peaceful living came to a sudden halt in the early 16th century. Starting around the year 1480, the ground around the town of Pozzuoli began to behave in strange and disturbing ways. Local residents noticed that coastal areas were slowly rising out of the sea, pushing the shoreline further outward into the ocean. Fishermen had to adjust their docks, and salt marshes that had been flooded for generations suddenly dried up into flat land. The earth was slowly lifting, but without modern scientific instruments, no one understood what was causing the ground to rise. For nearly 50 years, the ground kept lifting higher and higher, while minor earthquakes became more frequent across the bay. Then, in late September of the year 1538, the underground tension finally reached a critical breaking point. Over the course of just a few days, hundreds of sharp earthquakes shook the countryside, cracking house walls and terrifying local residents. Water along the coast receded dramatically as the ground rose several meters in a matter of hours, exposing sea life on the dry ocean floor. On the night of September 29, 1538, the earth literally tore open near the edge of the bay. A sudden, violent eruption burst forth, blasting steam, ash, glowing rocks, and mud high into the air. The explosion was so powerful that volcanic debris rained down over neighboring towns, forcing thousands of residents to flee toward Naples in terror. For a whole week, the new vent continuously spewed rock and ash, building up a brand new volcanic hill that rose over 100 meters high in just 7 days. When the eruption finally quieted down in early October, local residents returned to find a completely altered landscape. The blast had created a mountain that had never existed before, which locals promptly named Monte Nuovo, meaning New Mountain. Fortunately, compared to prehistoric explosions, the 1538 eruption was relatively small in volume and confined to a localized area, but it delivered a clear historical warning to humanity that Campi Flegrei was far from dead, proving that the caldera could wake up and erupt even after centuries of complete silence. Scientists who later studied this long cycle of rising and falling ground gave the phenomenon a specific name: bradyseism. The word comes from ancient Greek roots meaning slow movement, referring to the gradual uplift or sinking of the ground over years or decades without an immediate volcanic eruption. To study bradyseism, geologists look at historical buildings like the ancient Roman market building in Pozzuoli, often called the Temple of Serapis. This ancient structure has 3 tall marble columns that have stood near the edge of the sea for over 2,000 years. When scientists inspected these marble columns, they noticed something remarkable carved into the stone, not by human hands, but by nature. High up on the columns, between 2 and 5 meters above the ground, there are dense bands of small holes drilled into the marble. These tiny holes were made by marine mollusks, tiny sea creatures that bore into stone to live in shallow salt water. For those mollusks to drill into the marble, the columns had to be submerged underwater for centuries after the Roman Empire fell, as the caldera floor sank down beneath sea level. Later on, as the caldera floor lifted back up before the 1538 eruption, those same columns were lifted completely out of the ocean, carrying the mollusk holes high into the open air. This single building provided undeniable physical proof that the ground at Campi Flegrei acts like an elevator, rising up and dropping down by several meters over long cycles of time. It proved that the Earth's crust here is surprisingly flexible, capable of stretching and bending as underground pressures grow and shrink over hundreds of years. Are you enjoying learning about how Earth's hidden forces shape the surfaces we live on? Leave a comment below with your thoughts on whether you would ever live near an active volcano. And do not forget to subscribe to help us share real science stories like this with the world. For most of the 20th century, the ground under Pozzuoli was steadily sinking at a rate of a few millimeters per year. But in the late 1960s, the slow elevator ride suddenly changed directions once again. In 1969, precision survey equipment showed that the ground had stopped sinking and had begun to push rapidly upward. Over the next 3 years, the land raised by more than 1 meter, accompanied by hundreds of small earthquakes that rattled local homes. The sudden movement frightened local authorities, leading to the temporary evacuation of over 30,000 people from the oldest districts of Pozzuoli. After that sudden push, the ground quieted down for a decade, leading many people to hope that the danger had passed. However, in 1982, a second and much more intense wave of ground uplift began across the entire caldera. Between 1982 and 1984, the land pushed upward at an astonishing rate, rising by nearly 2 meters in less than 24 months. The rapid movement was accompanied by over 16,000 small earthquakes, cracking roadways, damaging historical stone buildings, and causing widespread panic among residents. During that intense crisis in the mid-1980s, scientists debated what was actually causing such dramatic ground movement without an eruption occurring. Some experts argued that deep magma was rising toward the surface, filling up shallow chambers and pushing the crust upward like a giant hydraulic jack. Other researchers suggested that superheated water and gases trapped in shallow rock layers were boiling under extreme pressure, causing the ground to swell like a steam boiler. While scientists analyzed the data, local authorities took no chances and permanently relocated thousands of residents from damaged waterfront homes to newly built housing inland. By late 1985, the rapid uplift phase ended as suddenly as it had started, and the ground once again began a slow 20-year process of sinking back down. For 2 decades, the caldera stayed relatively calm, giving local communities time to recover and adjust. But in 2005, the geological elevator changed direction once again, initiating the current phase of unrest that continues to this very day. Unlike earlier short bursts, this modern phase of uplift has persisted for over 2 decades without stopping, steadily accumulating upward movement year after year. Now, as we look at the situation unfolding right now, the story shifts from past history to an active, real-time science challenge. Over the past 20 years, the total ground uplift at Pozzuoli has surpassed the high mark set during the 1980s crisis. The ground near the center of the caldera has risen by more than 1.3 meters since 2005, pushing streets, houses, and ancient ruins to levels not seen in centuries. This continuous, relentless upward pressure is putting unprecedented stress on the solid rock layers that form the roof of the volcanic system. As the rock roof gets pushed higher and higher, it is stretched thin and subjected to immense mechanical tension. Think of a rigid plastic ruler being slowly bent upward in the middle. For a while, the plastic flexes, but eventually, microscopic cracks form, and if you keep bending it, it will violently snap. That exact cracking process is happening right now kilometers beneath the surface of Italy. Every time an underground rock layer fractures under the intense stretch, it sends shockwaves through the earth, which we feel as earthquakes on the surface. If you're amazed by how sensitive modern scientific instruments are at detecting these deep underground changes, hit the subscribe button right now and drop a comment below letting us know what part of this story surprised you the most. In recent years, the frequency and magnitude of these earthquakes have been steadily escalating, drawing intense scrutiny from geologists around the world. In the past, most tremors were too small for human beings to feel, registered only by delicate scientific sensors placed in deep boreholes. But recently, the earthquakes have grown larger, shallow, and much more noticeable to the human population living directly above. Swarms containing hundreds of tremors in a single day have become increasingly common, keeping residents on edge as furniture shakes and light fixtures sway. The depth of these recent earthquakes is a detail that particularly concerns scientists monitoring the caldera. Most of the earthquake epicenters are located very close to the surface, between 1 and 3 kilometers deep. Shallow earthquakes are much more dangerous to surface structures than deep ones, because the energy does not have space or distance to dissipate before reaching building foundations. Even a relatively moderate earthquake, at a depth of 2 kilometers, can deliver a violent, sharp shock to buildings directly overhead, causing plaster to crack and masonry to loosen. In late 2023 and continuing through recent months, the region experienced some of its strongest seismic events in over 40 years. Magnitudes reached 4.0, 4.2, and eventually peaked at 4.4 and 4.7 during intense seismic swarms. These major jolts sent thousands of frightened residents rushing into streets and public parks in the middle of the night, unwilling to sleep inside stone buildings that might collapse. Emergency response teams rushed to inspect public buildings, schools, and historical structures, discovering structural cracks in walls, displaced roof tiles, and minor damage to older masonry. What is driving this recent spike in activity, and why is the ground rising faster now than it did a few years ago? Modern geochemical analysis of gases coming out of local steam vents, called fumaroles, provides critical clues about what is happening far below. Scientists regularly measure the temperature and chemical composition of the gases escaping from Solfatara, a famous volcanic crater inside the caldera, known for its bright yellow sulfur deposits and hot mud pools. The data shows that the temperature of these steam vents has been rising, and the chemical blend of gases is changing rapidly. Specifically, scientists have detected an increasing ratio of carbon dioxide and sulfur gases compared to normal water vapor. When deep magma degasses, it releases carbon dioxide first, because that gas escapes easily from molten rock at high pressures. The increasing concentration of carbon dioxide rising to the surface suggests that fresh magma deep underground is actively releasing gas into the shallower hydrothermal system. This gas acts like a pressurized aerosol can, driving up steam pressures in the rock layers directly beneath the feet of local residents. Furthermore, superheated steam and volcanic gases are not just pushing the ground up, they are actively altering the physical strength of the rock itself. As acidic steam forces its way through tiny pores and cracks in the stone roof, it chemically reacts with the minerals in the rock, turning hard granite and tuff into soft clay. Geologists refer to this process as hydrothermal alteration, and it effectively weakens the structural ceiling holding the system together. A weaker roof means the rock cannot withstand as much stress before cracking, leading to more frequent earthquakes even at lower pressure levels. If you find it fascinating how heat, water, and gas work together to reshape the Earth's crust, make sure to subscribe to our channel and leave a quick comment below with your thoughts on how science helps protect cities from natural hazards. To gather even more data, international teams of scientists use cutting-edge technology that feels almost like science fiction. Satellites orbiting hundreds of miles above Earth bounce radar waves off the ground every few days, measuring changes in elevation down to the millimeter. This technique, called interferometric synthetic aperture radar, or InSAR for short, creates detailed color-coded maps showing exactly which neighborhoods are rising, which are staying still, and where stress is concentrating most heavily. On the ground, researchers have installed a dense net of continuous GPS receiver stations, tilt meters, thermal imaging cameras, and borehole seismometers. Tilt meters are incredibly sensitive instruments buried deep in soil that can detect changes in ground slopes smaller than the width of a single human hair over a distance of miles. By combining satellite radar data with ground sensors, scientists can construct a three-dimensional real-time map of the subsurface pressure bubble pushing up against the city. The big question that every scientist, city official, and local resident wants answered is simple. Is an eruption imminent, or is this just another long phase of non-eruptive underground stretching? To answer this, volcanologists run advanced computer simulations that model how rock fractures under pressure. They look for specific warning signs, such as earthquakes moving closer to the surface in a linear trail, which would indicate that magma is actively carving a pathway toward the open air. As of right now, monitoring data shows no definitive proof that a large volume of liquid magma has broken through the shallowest rock layers to reach the surface. The continuous uplift appears to be primarily driven by a combination of high-pressure volcanic gas injection and shallow magma heating from a depth of roughly 3 to 4 kilometers. However, scientists emphasize that even if liquid magma does not erupt immediately, the ongoing earthquakes and ground deformation pose severe risks to local infrastructure and daily human life. The human element of this geological drama is what makes Campi Flegrei one of the most critical risk zones on the planet. Unlike remote volcanoes located on uninhabited islands or high mountain ranges, Campi Flegrei sits directly beneath dense urban development. Over 500,000 people live inside the defined red zone, which is the area at direct risk from dangerous volcanic flows or heavy debris if an eruption were to occur. Another 1 million people live in the surrounding yellow zone, where heavy ashfall could collapse roofs and disrupt transport networks. Evacuating 500,000 people from a dense, historic European urban area is an extraordinarily complex operational challenge. Roads in the region are often narrow, winding through historic districts that were built centuries before automobiles existed. A sudden evacuation triggered by panic or a major earthquake could lead to catastrophic traffic jams, blocking emergency vehicles and leaving people stranded in vulnerable areas. Because of this, emergency management officials have designed detailed evacuation plans that rely on early warning indicators to move citizens out days before any potential blast could occur. The Italian Civil Protection Agency regularly reviews and updates these regional emergency plans, dividing the caldera into distinct safety zones. They conduct large-scale public simulation drills where thousands of volunteers practice boarding buses, trains, and ferries to relocate to other regions of Italy that have agreed to host displaced residents. These drills help test communication systems, road networks, and public awareness, ensuring that if the alert level is ever raised from yellow to orange or red, the population can move in an organized, orderly manner. Living with the constant threat of earthquakes and volcanic uncertainty takes a heavy psychological toll on local residents. Families keep emergency bags, packed with medicine, documents, and supplies near their front doors, ready to leave at a moment's notice. The sound of a sudden rumble or the rattle of kitchen dishes causes instant anxiety, forcing people to decide in seconds whether to stay inside or run out into open squares. Yet, despite the ongoing fear, many locals express a deep emotional bond with their land, refusing to leave the homes where their families have lived for generations. When we consider what a potential eruption at Campi Flegrei could look like, it is important to distinguish between small-scale events and catastrophic super eruptions. Media headlines often refer to Campi Flegrei as a super volcano, invoking dramatic images of global disaster and mass extinction. While it is true that prehistoric eruptions here were truly massive, scientists emphasize that a future eruption is much more likely to be a small to medium event, similar in scale to the 1538 creation of Monte Nuovo. A small to medium eruption would still be serious for the immediate area, potentially involving steam explosions, localized lava flows, and heavy ashfall. A steam explosion, known as a phreatic blast, occurs when trapped. Groundwater gets heated by shallow magma and turns instantly into expanding steam, blowing out chunks of rock without releasing liquid lava. Such an event would be localized but highly destructive to buildings and infrastructure directly surrounding the vent, underscoring why strict monitoring and rapid evacuation capabilities are so essential. On a broader scale, Studying Campi Flegrei helps scientists better understand other giant caldera systems located around the world. Places like Yellowstone in the United States, Lake Taupo in New Zealand, and Long Valley Caldera in California share similar geological traits with Campi Flegrei. All these massive systems experience long periods of ground uplift, earthquake swarms, and gas releases without necessarily erupting immediately. By gathering high-resolution data at Campi Flegrei, researchers improve their global mathematical models, helping predict volcanic behavior for communities living near calderas worldwide. The story of Campi Flegrei is an ongoing narrative where nature and modern human civilization meet in a dynamic, unpredictable dance. It shows us that our planet is far from a static, unchanging rock. It is a dynamic world powered by vast heat engines deep underground that operate on timescales far longer than a human lifetime. Modern technology gives us an unprecedented ability to listen to the Earth, translate its subtle vibrations, and prepare for whatever changes lie ahead. As scientists continue to monitor every tremor and millimeter of ground shift, humanity learns to adapt, respect, and coexist with the incredible natural forces that shape our world. If you enjoyed this deep dive into the real science behind the restless ground of southern Italy, please subscribe to our channel right now and turn on all post notifications so you never miss a new video. Drop a comment below telling us what you would do if you lived in a city built on top of a dormant volcano, and share this video with a friend or family member who loves fascinating science stories. Thank you so much for watching, and stay curious until next time.